Your AI tools work perfectly, but their output structure is holding you back from seamless integration with other systems. You'll see how to completely redefine a tool's output schema in FastMCP, forcing structured responses that match your exact requirements, not the original implementation's defaults. This pattern ensures downstream systems get predictable, validated data every time.
Tool, from tool, parent tool, output schema equals. Type, object. Properties, status, type, string.
This demonstrates the adapter pattern applied to tool interfaces, where existing functionality is repurposed rather than rewritten. The technique creates specialized tool variants by wrapping base implementations with modified schemas, behavior, or metadata. What distinguishes this approach is its non-destructive nature. The original tool remains intact, while transformed versions adapt it for specific contexts. The pattern operates through declarative composition rather than inheritance. A transformation layer intercepts calls, optionally modifies inputs or outputs, then delegates to the original implementation. This separation allows independent evolution of interface and implementation, with transformations handling concerns like validation, argument mapping, or output formatting without altering core logic. This approach solves the almost right problem where existing tools need minor adjustments for new use cases. It eliminates boilerplate wrapper code while maintaining a single source of truth for business logic. The trade-off is slight runtime overhead from the adaptation layer, but the benefits, reduced duplication, clearer interfaces for consumers, and easier maintenance, outweigh this cost in most scenarios. Let's break it down line by line.
Tool, from tool, parent tool, output schema equals.
This creates a derived tool from parent tool while explicitly defining its output schema. The schema enforces structured return values, ensuring AI models receive predictable, type-safe responses.
Type, object.
This defines the output as a JSON object type, not a primitive. It enables structured responses with multiple properties, which is required here since we're returning a status field.
Properties, status, type, string.
This defines the output schema's property structure, specifying that the tool must return a JSON object with a single required field. Status as a string. It enforces strict response validation, preventing malformed outputs from reaching downstream systems. Closes the dictionary and function call, finalizing the tool creation with the specified output schema. This ensures the tool will return structured data matching the defined properties, enforcing type safety for the status field. Schema transformation pattern. The output schema parameter in tool from tool gives you surgical control over how parent tool behavior propagates, letting you override, remove, or completely redefine the structured output contract. Specifying output schema equals none doesn't disable structured outputs entirely. Primitive returns still get auto-wrapped in result. Value by the MCP protocol handler. The most flexible approach combines schema control with transform functions, where you manually construct tool result objects for complete authority over content, structure, and metadata.
The schema that constrains the tool is the same schema that sets it free.